a second example where we are writing an equation for a given graph. Hopefully you watched the first one, and just be aware you have lots of options here. Unless it's asking for a specific sine or cosine equation, you can kind of decide, would you like to do a sine or cosine, or reflected sine or reflected cosine. I am going to go ahead, as I look at this, choose, I think I did a sine or cosine in the last one. I'm going to pick this sine cycle right there. Alright, so I'm going to write an equation for that. Starting with the amplitude, two ways to find that. If you want to go ahead and draw the midline, that line that cuts it halfway through, that's like your new x-axis. Because remember, your sine graph is centered around that before any vertical shifting may happen. I can tell that the amplitude will be from here to the top or to the bottom, which appears to be 2. Kind of hard for me to read this graph right now. The other way to think about how to find that is if you look at the entire total height from the top of your graph to the bottom of your graph, which is 1, 2, 3, 4, and if you just cut it in half, you know that your amplitude will be 2. Alright, your period, if you know your amplitude is 2, that's giving you your A value. The period from the start of your graph to the end of your graph, you want to know how far is that distance, from the start of your cycle to the end of your cycle, what that distance is. Sometimes I like to just count up the spaces, 1, 2, 3, 4, 5, 6, 7, 8, and then just compare. If you looked at the 0 and went 8 spaces, you could see we'd be landing at 2 pi. So our period must be 2 pi. And then you want the b value out of that. So if you remember that 2 pi over b is how you find the period, think about what did you divide by to end up with just a 2 pi. And I think this happened on the last one also. We end up with a 1 for b, because 2 pi divided by 1 equals 2 pi, which is our period. Horizontal shift. Because our sine cycles do start at the origin and on the y-axis right there, I can tell that there has been a horizontal shift. So from the y-axis, it went over how many spots? Well, it looks like to the left 3. What we do want to remember, though, is that I can't say to the left 3 because our x-axis is labeled in terms of pi. So what is 3 spaces in terms of pi? Well, 1 space is a pi over 4. And if I'm going to the left 3 of those, that means I must be going to the left 3 pi over 4. Our vertical shift, you can find your vertical shift by just comparing the new x-axis, that midline we drew in, from the original x-axis. So from here up, that was the vertical shift, and we can see that it went up 1. Alright, now we're ready to write the equation. Start that with y equals. This time I'll go ahead and I'll put the vertical shift at the beginning. You really can put it wherever you want. Because the vertical shift is going up 1, I need to make sure that that's a positive 1. This is not a reflected graph, so I know that our A value will be positive in our equation. So next comes the amplitude, our A value of 2, times the sine or cosine. We decided this would be a sine graph. Next comes, because there's a vertical shift, our B value. Well, the B value is 1, which means we don't necessarily need to write it in. And then x plus or minus, I guess I should be saying this is our C value of 3 pi over 4. And our D value is 1. So x plus or minus that C value, because we shifted to the left, that tells me that there must have been a plus sign in the equation, that tricky x. The sign in the equation is opposite from the shift that happened. So x plus that 3 pi over 4. And then the vertical shift we took care of in the beginning. So there is our equation for the shifted graph.